Alrighty, so here is another example of a problem with bearings and vectors, because bearings can be seen as a vector because a vector has force. In this case, it's going to be length and is my magnitude. Alrighty, because magnitude is length. So if we look at this, we are told a ship leaves port on a bearing of 28 degrees and it travels 8.2 miles. The ship then turns due east and it travels for 4.3 miles. How far is the ship from port? And what is the bearing from port? Alrighty. So here's my ship. Man, that's a beautiful looking cargo ship right there. Now remember, bearings are always taken from due north. Ooh, that is not what I wanted to draw in the slightest. Not what I wanted. Boom, 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 boom. Let's get rid of that. All right, let's try that again, shall we? So my ship is going to go from due north. We are traveling at a bearing of 28 degrees. Alrighty, so 28 degrees. Let's do it in this nice green. So a bearing of 28 degrees is going to be from north. We're going to come clockwise 28 degrees. So about like so. And that is 28 degrees. And we traveled 8.2 miles. So there is my magnitude for that green line, 8.2 miles. Then the ship turns due east. And we are going to travel 4.3 miles. Okay, so we are going to now turn due east. East is to our right. And that is only going to be about 4.3 miles. Not about. It's only 4.3 miles. So I try to make it about half as long as that 8.2. Now the question is, how far is this ship from port? So my question is, now the ship is right here. My ship is no longer down here. Oh, come on. There we go. It's now here. And I want to know that distance from port, and I'm asking you to find that angle. Those are the two things that we're asking. Okay, so the first thing I'm actually going to find is, oh my goodness, so I want to find this length. So the question becomes how? Well, let's see. I know that this is, so what I'm looking at. Okay. So once again, keep in mind, I've already done these problems beforehand, so I know exactly how I am going to attack it. So if you're like, how does he know this? I sat down and I figured it out. I tried something, and if it didn't work, I tried something new. What I know is right here. Let me change up colors. Right there, if I was to connect that, I know this angle would have to be 90 because coming straight to the right off north is a 90-degree angle, and there is a 28-degree angle. I know all three angles in a triangle have to add up to 180 degrees, so that means the angle right here would have to be 62. And if this angle on the outside is 62, the angle on the inside plus the angle on the outside, these two together, also have to add up to 180, because you can see right there they make a straight line. That's a very, so we get that. I know this angle right here is going to be 118. Hey, check it out. I know a side, and I know two sides. I know the angle between those two sides, and I want to find the side opposite. That's going to be the law of cosines. I almost said the law of cosines. It's the law of cosines. So the law of cosine says the side I'm looking for squared is known side squared plus other known side squared minus 2 times a times b times cosine of the angle that's opposite the unknown side. So we're going to find x. I know A. I know B. Minus 2 times 4.3 times 8.2 times the cosine of 118. Boom, 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 boom. So I put all of that into my calculator, and I end up with x squared being 118.8371346. Take the square root of that answer, and I'm going to get that this unknown side is about 10.9 miles. I am about 10.9 miles away from port. Now, they want us to find the bearing from port. So bearing from port is going to be this whole thing right here. So we're going to find this little out. We're going to find theta right there. So the question becomes how? Well, in this case, I am going to use the law of sines. Law of sines says the sine of an angle over the side opposite. So the sine of 118 over 10.9 equals the sine of an angle, we're going to call it theta, over the side opposite, 4.3. Now we can cross multiply. 10.9 sine theta equals 4.3 sine 118. Divide both sides by 10.9. So 4.3 sine 118 over 10.9. And then we get the sine of theta is about 0.3483187752. I take the inverse sine of that, and we find out that theta is about 20.4 degrees. Now what we have to be careful. We got to look back, and we need to ask ourselves, what did it want? It wanted the bearing from port to the ship. It wanted this whole green one. What we found was this part of it. So the bearing from port is going to have to be that initial 28 degrees right there, that initial 28 degrees, plus theta, which we just found as 20.4. So the bearing from port is going to be 48.4 degrees. So here is how far the ship is from port. It's 10.9 miles from port at a bearing from the port to the ship of 48.4. So if you've got any questions for me, please come in, ask those questions. I'd love to help you. You know, I love to answer them questions. We are actually going to do example number 9. I'd like you to take a look at it. We're going to do that together in class. So it's a really good one to do. So I'll see y'all when I see ya, and I hope you have a good one.